Hi everybody. There's one more thing I want to talk about when it comes to doing lines, is that there are a lot of really strange, nuanced cases. So I want to talk about this, nuances of drawing lines. I'll be honest, I don't like this stuff. This is boring. This is annoying. And I'm less concerned with you knowing exactly like to fix every one of these cases, but you need to understand this is something that people work at. So here's the problem. Let's draw some lines. I'm going to draw a line like this. I'm going to draw a line to here, and then I'm going to draw a line from the same spot down to here. Okay? And then first thing we notice is you draw a line like this. And then I draw this line. What do I do here? Same coordinate, right? Do I draw it twice? Do I draw it once? And the first time, do I draw it the second time? If this is a red line and this is a blue line, then the rule here changes how that corner point will look. Will it be red, 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 red like this, and then blue capping like this? Or will it be the other way around? Right? Will it be like this? Or will it be somewhere in the mean? Will it mix them? And then I'm going to start filling this polygon with lines. And I want to make sure that it fills properly and there's no holes left in here. No holes. In old computer graphics, you sometimes see a hole along the edge there that you can just barely see through, right? We need to ensure no holes. So these little nitpicky details end up being really important. It can ruin your graphics demonstration if you're seeing these little seams and lines come through. Again, if you've played a PlayStation 1 or played some really old video games, sometimes you'll see this pop out. It's a problem we want to take care of. So I'm going to explain one way that this is taken care of, and it's called the diamond exit rule. And all that this is, it's a standard that if everyone agrees on it when you're drawing in a library, you'll solve these problems. This is just a standard drawing rule to ensure proper cover, proper fill, and no overlap. Okay? So the way that this looks is I'm going to draw a few pixels here. These are pixels. And then you can imagine that inside each one of these pixels we have a diamond. Just a pretend diamond. It's not real. Okay, you have diamonds in all of these. You can imagine they all have diamonds embedded in them. And then when I go to draw a line from this pixel, let's say to this pixel, the diamond exit rule tells us whether or not to draw to light up that pixel. So first, we imagine each pixel has a diamond embedded. Okay? It's called the diamond exit rule because, you guessed it, if the line exits that diamond, if the line exits the diamond, then we draw it. Where am I? We light that pixel. Okay? So it's that simple. If it exits that diamond, so I'm going to use a different color here. Here we have an exit, no exit. So this last one isn't covered, isn't lit up. OpenGL uses this. OpenGL rasterizes using the diamond exit rule. Now I can hear what you're saying. Oh, Jim, I'm just starting to figure out this Bresenham rule thingamabob for running lines, and now I got to learn this new thing, this new diamond thing. Well, it turns out, good news for us, Bresenham's, I should probably capitalize this poor guy's name. Bresenham's algorithm, and I'll put a caveat in here, with if it's done properly, right? Because you can have the vector and the increment at the wrong spot, and you could have it working, but you increment before you check before you increment. If it's done properly, then it actually gives you the diamond exit rule for free. Right? Awesome. So this algorithm we covered up here, I didn't really highlight this before, but I want to highlight it now. Look, we put the pixel, then we do our moving, and then if we moved and the while loop finishes, we don't draw that exit pixel. Why? Look, we didn't draw the last pixel because of the diamond exit rule. That's really cool. So I'm going to zoom in even a little closer. I want to talk about a few special cases here. The diamond exit rule highlights some really strange things. First of all, if I draw, I guess I should note this first. Because of rational coordinates, right? Our coordinates can be 0.45, whatever. It doesn't have to be a full pixel. If I have this drawing from here to here, it exits the diamond. Ta-da! It lights up. If I draw this, from here to from here to there, I'm gonna draw arrows in here. That's what I should do. If it goes this way, I enter the triangle, right? But I don't exit it. You don't light up. If I draw here, inside and I don't exit, we don't light up. So a few things that comes out of this. First, the direction of line matters. Okay, this one here exits. If it was reversed, it wouldn't draw. Okay, and then the other thing is that some lines are not drawn. Okay, so that's it. That's the diamond exit rule. Again, I'm not too concerned with like exact figuring out all the little edge cases, but if you think about this after you get your head around it, it's actually not that bad of an algorithm to understand. Implementing it is the pain, but I just told you, Bresenham's line algorithm, it implements it for you. So this should not pose as a problem for you. Here's an example of a slide. We're rasterizing this triangle here. Let's see if I can make my thing a little better. We're rasterizing the triangle here. Cool. And you see, exit this triangle, yes, exit, 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 exit. These all get exited, so we light them up. We go this way, exit, yes, exit, enter, exit, enter, exit, enter, exit, enter, exit, enter, exit, yes, not the last one. It also means if we have cases where it does go through a pixel, but you can imagine cases where, I'm going to make up a line here where it goes through a pixel of this. Oh, I did it wrong. Let's try over here. You can imagine going through a pixel this way and not being curvy, light up. And these pixels here wouldn't get lit because it's not exiting the diamond. Okay, so that's it. That's the diamond exit rule. That's all you need to know about that. Next, we'll move on to filling triangles. Thanks.